guys, welcome back to another Leetcode daily, and we have today letter tile possibilities. It says you have n tiles where each tile has one letter printed on it. Return the number of possible non-empty sequences of letters that you could make using the letters printed on those tiles. So basically, have n tiles, right? And each tile has a letter, and then it just wants the non-empty sequences of letters you can make. So basically it's something like a permutation, but it's not a permutation because permutations are the same size, but like just different variants. So basically A, B, double A, B, like anything you can like possibly get, just add basically. And it just wants the total count of them. And bear in mind the tiles length is 7. So this is a classic backtracking problem because the constraints are very, very low. So basically, and tiles has uppercase English letters. So this thing is basically 26 locked in. It's gonna be of size 26 always. But anyways, because because when deriving the answer, the ordering is not important. So basically you can have B first when B comes last in here. So something like a hash map to actually count the occurrences of every single character is very important here, because you need to start from a different character every often. I'll try to explain this as best as I could, but yeah, so you need to try doing this by your hand, or there is the question permutations in Leetcode. I recommend you solve it first. It will give you an idea of what's going on in a way. But I used the hash map with a counter and a scene set to just count the number of so scene basically, if I, because we have double A's here, right? If I see a once and see it again, it's just going to be counted once, which I want. And then I have this so far string is basically the string I constructed so far. Basically, I add it in the scene array, and then I use this hash map. I have the counter, and then I iterate on them, right? If the count is greater than 0, I subtract from that key 1, and then I append it to the string. Obviously, appending to the string is not the most efficient thing. You can have an array and then join them in the end, whatever. It doesn't really matter. But you can append it to the string, and then I give that, and then I give the character its count back. Basically, why? Because when you subtract and then you DFS, you go through the journey starting with this character. You want it back because there's another iteration going to happen with a brand new character. So basically, if this is the first ever DFS to happen, it's gonna happen for every single character here, A and B. So yeah, it's basically okay. So backtracking is more of practice than actually explaining, but this is how it actually goes. For time complexity, we have 26 characters here, right? And worst case is we're gonna have a string of size tiles. So it's probably 26 to the power of length tiles, where you have 26 options, and length tiles is n basically. You can have, but it's 7 in our case due to the constraints. But yeah, it's 26 to the power of n. Yeah, hope I explained it well enough. If I didn't, leave a comment below. Thank you guys for watching, and see you in the next one.